Hello, and welcome to another video. So we've been working through this BitTorrent program, and I mean we've just been stuck at this downloader piece for a while. Not because it's hard though; it is somewhat hard. But I've been doing quite a lot of, I guess, like admin. So I've actually published a bunch of the header-only libraries. I think I want to like close off some stuff. We can close off that and come back to it just to see what's what. We don't need that. What was down here? We don't need that one. Cool. And what about these? That's linked to it. Cool. So what I've got is a few libraries. The SDB style, the Sean Barrett like header only libraries. So all you need is this one file, and you should be able to do some bin code decoding, for example. And then in this one, you should be able to do some URL parsing. And this one, you should be able to do some SHA-1 parsing. And then there's also bin code twice. We can probably close one of those. And there's also this HTTP, which can do a bunch more. So this makes requests. You have to do a bunch. And the other thing that I've done off screen, because it's kind of like, it's interesting, but it's also not. I think I want to just bring that up a little, and maybe, no, we won't have that just yet. Oh, I want to get this yet. I have to remember what keys I want where. So a thing that I did off screen was I don't even have it. Was I used a tool called AFL Fuzz. Well, in fact, I used AFL AFL yeah, which this basically fuzzes stuff, and it can help find like memory issues in a sense. There's like a bunch of things you can do to find memory issues. This is just one of them. So, for example, like you can see, I have made a few commits doing some stuff. Is there a way to like see them all, but like see the version maybe of this file with the yeah, I kind of wanted to see what it was doing as well. But we can see here like there was an issue that content length could have been negative, and that caused some issues. Also added some stuff. So I've done a bunch of testing on these single header libraries, and I feel a lot more comfortable saying that they are somewhat decent. They're still like alpha quality, like the HTTP can't get much, but I'm confident that the response that the server sends you probably won't screw up your system. I say probably. So I guess that's kind of a first little thing. I should probably update this one to say that I also now support the bincode.h. But yeah, that can be another time. That kind of felt a little strange. Probably shouldn't. There's like a scar there. My brain might fall out. Quite literally. But what I think I want to do is actually get back to the code that we were working on, which was the BitTorrent client. I couldn't do this for some reason. So this does have. What about this one? Yeah, so this we are doing some stuff, and we're getting up to a certain point. So what we're doing, we've actually sent off all these requests, and if you look at the network, we've actually received all the blocks that we want. But what we need to do now is we need to actually kind of process each of these messages coming back from the peers, and these peers, this peer communication will probably be pulled out into a library of its own because it's kind of useful. But I don't know if that's just overdoing it or not. But yeah, what I want to do is, yeah, I kind of just want to do this part and see how far we get. Um, so, what do we do? We haven't implemented this. So I think I want to maybe go like that. I'm aware that you might not be able to see a certain portion of the screen, so maybe I will do not that, this one and that way. So we can kind of see the screen and you can see roughly what is happening up there. So what message are we waiting on? So we can probably start this. Actually, let's message ID 7. This was the one saying the IDs. So we have now got a piece, and it came after request, which we don't actually handle. We just do the bit field. But I guess to keep it kind of numerical, we can do it here. And what have we got? We've got a piece, and we'll start off a thing, and we'll do a break. And that didn't make a new line there. So what's going to happen in this piece packet? So this probably says what it is, but I think I might switch to this because it says it in a nicer way, and it's dark mode, which I think dark mode is just required if you want to do videos like this, because people watch it at night time, believe it or not. So we've got a piece, and this should get some packets. So I guess I'll just remind myself what happened after the bit field. So payload we don't care about. So maybe I will look at the unchoke. So the unchoke is what we do after we get this, and then we will send some stuff. But this does have a payload, so we can see here. Well, the payload is empty. I'm just kind of trying to remember how it is that I was doing things. So I guess like this is kind of what's going to happen. In fact, like it's almost the same thing. So yeah, I see what we've done here. We've actually kind of made things like this, and maybe this can be called a piece payload. And what does it have? It has index, begin, and block. But this is going to be like pointed to golly, maybe I can go like that. Ooh, 24 minus, or 23, 24 decrement. But yeah, so this is going to be a block. So it's going to be a pointer. So what we have to do is kind of see what the maybe let's go back to where we were. So this is kind of the packet that we're receiving. So that's like writing it. I think what's happening is we're just saying the payload is what is payload set to? So yeah, it's just a single byte. Right, so I see here. This first one, we have to read it, but it was a single byte, so we do need to kind of read the payload until we get it. No more reading there. This, the bit field, well, that was that. So theoretically, this should be empty, but I guess it is not here. And then here we have this, but the payload here we don't actually set, do we? Because like here we've got a payload, and here we've got a payload, but I see, I see, I see. Right, so I guess here I want to maybe let's do some printing. So we've got packet length, and this is going to be equal to or u something. We're also going to have like a well, in fact, let's just do that and see what that does. And so if we do this now, it should complain about that. It's just a U. So packet length is just 1. So because it is 1, that means I feel like it should be more than 1. Because we want to kind of just read it into this type of payload. So we go here. So we will have a what do I call it? Piece payload. So we're going to have a piece payload, and we can just make it equal to null 0 initialize it. And what are we going to do here? So I kind of want to just read and see whether I can read it. So what if I do something like this? Does that do exactly what I want? And if got payload, and we can see if it ends or it doesn't end. You got to do this. So bad type 101. Let's just make you a U. And we'll get rid of that bad type. Wasn't expecting that. That's because we're like kind of mid-length of things. So here we got that. So I think I actually just want to like complain here. How were we complaining for? Maybe I'll just do this. Maybe I'll add in a thing. Printf std here, and we can put a s and a d and then a implemented. We've even got it. So if we did that, and then we have to pass in well, I guess file and then a line also. And so then we should have a fail out on the first time we reach it, because what I think is it's going over and over, and I want to see what's happening on this first one. So the packet length is a fair amount of stuff. So we read 16 bytes there. Now this 16 bytes isn't quite right, because the block is going to be just all of the data. So I guess we just need to know how long block is based on that. Um, well, I guess we know the size of the whole file, and we need to write the whole file at some point. Or the whole block piece. That's what it's called. So we should allocate some memory for that then. Because we're asking for this much, but we're also doing it several times. So how do we do that request? We have a piece length. Excellent. That will be what we want, I would imagine. Let's grab that and let's go back here. And I guess we can have payload dot block equals mallet of where do I have it? It's there. Is that what I want? So that's going to set it to. I think we don't want. I think I don't want this in here. Because it doesn't really, yeah, it doesn't really, really, I just want to get those two things from the thing. I think I don't want to do that. It was useful in the request because we're sending it over and over, but here we really just want a uint32 type index, index, and also begin. We can probably not do that, and here we can go index and begin. And so here we can say got index equal to d and begin equal to also d. And so I guess here we need to pass an index and begin. And so now we should be able to work out how much data is left based on that. So that seems about right. Index is that. Index does not seem right. I am going to be honest with you. And I think that is because we need to do some verting. So we want to do something like index equals, we want to, I guess, go from the net to the host. And we don't want it to be that, we just want it to be of itself. And then we also want to do the same with begin, like that. And then the numbers should be hopefully 1. Yeah, because that is what I have in my make program, I believe. ERD, we are trying to get sample 1, the 1 index. So I guess, yeah, I want to save this somewhere. And for this exercise, we actually do have to save it to a file. So we actually have a output file, which we probably could do seeking to. I don't know if that's a silly idea, because no, not. I kind of want to make the output file exactly the size that it needs to be, and I don't know if I can actually do that with C standard library. I might have to do a open, um, like an actual open, because that is kind of what is happening here. But the O trunk is. No, that just truncates it to 0. So I think if I look at maybe the second man page of Oaken, so the flags I want kind of like I want to just make a file of a large size, but not actually allocate any, like not actually write anything to it. And I wonder if that is um, possible. I also wonder if this is now just making it not uh, like platform dependent, but it probably isn't already. Block. Yeah, I'm not too sure how one might do that. Um, Maybe this is where our old friend Google can help. So I guess if I wanted to search that, C create file of bytes, because like uh, so we could just do that. Yeah, that works. And there's also f truncate. Easy. F truncate looks like what I want. So here we can probably go. Do we have piece length? We should have it here. So we could probably go F truncate, and what would the outs to be pieces size? Something like that. Is that how we do this? And use the types. That's good. And this needs to be file no of that, I believe. But do you should not fail? That's cool. Yeah, so I guess this we do kind of need to detect. So I guess we can have int out fd equals file no out. Maybe we could do this like up here and if out fd this is less than 0, something is weird. So I guess we could probably go to in here because we do have something open theoretically. This is a weird error though. So we could probably say uh, it's probably an IO error. I'm going to be honest with myself, and this is data error. That's what it was. Cool. So then down here we can do this, but maybe change to that to be out the and what do you return? 0 is return -1 and do that. So I guess if this whole thing is less than 1, we can just go to the end. And maybe this can be back to being a IO, 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 and then back to its data error again. So, what that's going to do is it's going to make sure that the file is of the right size, hopefully. So I guess that kind of been. Now, got a small issue. If you were doing concurrency, like multitasking, like how it actually suggests in the thing optional. So to improve speed, you could send more than one, perhaps five. So if I did that, I would have to be very, very careful with the memory and who's writing what, when, and who owns the memory, and all of that. I'll probably do it because I don't know. I'm kind of liking doing everything from scratch. So, what do we do next? So we have the index, we have the begin. I reckon we could probably just let's read full, take away our no, but we could probably go packet length minus equal to uh, size of, and we can do index and do begin. Is that how you can? Do you have to do the size of operator on the thing? This will tell me if it will work or not. It does something funny. Oi. Oh, I think we're like getting that error maybe. Your BitTorrent and echo dollar that we're getting 74, and if we this exits 74, that is IO error. Cool. So I guess is that because the truncate is failing? So printf truncating. Ideally, it would have better error messages, but sometimes you don't. Yeah, so it's failing on that truncate, and I wonder if it's because to B and this is size. We can do this. Okay, 60. Now, is that right? I feel like Truncate did say that you should do it differently. So I feel like I was doing this correctly. And I feel like we should have 60 gigs. 60. Yeah, we've definitely got the bytes free for 68. D do that, and maybe let's put in out FD. Truncating one to that. Is that because I'm trying to be too fancy? Yeah, I'm trying to be too fancy here, and I'm specifically allowing output to STD. So I guess for the spirit of the competition, I might do something like this, and that way we can move forward with it. And if we're outputting to standard error, maybe here we can fix me if out fd is can we do this? Then do stop. Oh, got that heartburn. Not a fan. Right, so if we go here, maybe put you back here, and we can get the you. So now we're getting a bit further. And I think if I look real closely at peace, it's 60 points. So I wonder if peace is meant to be a lot more than that. Like, it just seems real small. I didn't want to do that. I wanted to do that. Gosh. So if it is like this, what do I want to do? I think I want to look at this and little cookies. The 60 just seems too low. So we get this from the piece length. You talked about the piece length. Yeah, piece length maps to number of bytes in each piece the file is split to. Piece length does not seem right. Piece's size. Especially because the number of bytes that we're so called getting is heaps. So packet length, did it say what packet length did become? Packet length was a substantial amount. What do you do? Read full, we define common. Come on, I've split things up a little. Right, so we just want to read everything that we can into the buffer that we can, and we just try and read it, and it will complain if we can't. Cool. What about yeah, so I think I want to say if packet length is less than size of 32 times 2. That's bad. We might have another of these little cookies. No, don't go there, go here. Yes. So I want to take off size of 32 times 2. So we're getting 2 things, and packet length is still that. So we should have a bunch of things, or take me back to where I was saying. We just haven't done this. F, HTTP error, expected, what was it, index, and begin, only, uh, something like that, and then we can say packet length, and we can probably go to the end there, and then we can say this, and like these shouldn't really fail. If they do, that's like a different thing. So we didn't want the L on that. That's all right. So we still have quite a large packet size, and we're only expecting 60. And what I could do is do this TCP flow, and this will actually show me what is happening over the network. We can scroll up past all of this, which is ironically just all the data has arrived on our computer, but we just haven't done it. So what was the message we were getting? We were getting a message ID of piece 7. So we have to read through all of this to work out that this is piece 7. We have a nice little 7 there. So how do these packets go? Message length prefix, message ID, and then the payload. So this is the length. That's that. So I guess this length, it just seems like that's more than 60. So how do we get the who tells us the pairs? That, but it's literally just in the torrent file, so there should be a pieces link, and it is a gigantic number, but there's also 60. I've seen what I've done. So the truncate, we actually want to get piece length. Piece length, and the size is going to be that. Cool. So now it should won't say what it did truncate to, but if we look at piece, it should be a larger number. Cool. Now it feels a bit safer to just go and do some seeks. So I guess at this point here, we probably could just go f seek, and we want to. Do you take the file? You take the file. So we will give you out, and we will want to seek. Let's offset them weights. So we want to seek to begin. We're just trusting it's good. We probably should fix me validate. These are in range. So we get the begin, and then we get the seek set, is it? That looks right. We'll look at it. Yeah. So if this whole thing fails, it will give us a 0 or a -1. Perfect. So if this is less than 0, we can potentially go rect equals x io, something happen, and then go to end. And I think if this happens, I do kind of want to hear about it, because it seems like an unusual one. Could not seek to where we go? OU in output file. That can be that, and we just want to go to begin. And so then it does want just you. So then we should get this. We're still crashing at the same place. That's perfect. I think we don't lose it. I think I just want to do these. So validate begin and index in range. So the index, we actually just want to, for this function, if index not equal to piece, that's a problem. And this is expected index, and we expected index of D, and we got that, and these are we expected piece, and we got index. And here we can go to end. What sort of error would this be? This is like a data error. This is like a network error. Do we like set ret? So we do set ret to be protocol at that point. Otherwise, we set it to software. So this whole thing is protocol. That is probably all right. And it's all protocol. This is potentially still protocol, and this is just IO error, just a little one-off case. So what this should do is it won't really make any change here. I shouldn't run it as often. Right, so we want to make sure that is the case. We can probably get that, and maybe get rid of that and go to this point here. Right, so what do we want to do? We have seeked to the right part of the data, and now I kind of want to, while packet length is greater than 0, we want to do a thing. And I think I actually have this up here that we kind of read stuff in the bit field. But in the bit field, we don't actually do anything. So we could probably call this data, I guess. And we could probably just go if right. Is that the call that we need to do? What I forget, but there must be a very valid reason why they put the file on the end here, but not for like just all the other ones. Like how I think I can get to that manual if I go to just stdio. It doesn't show the signatures, but I mean like if truncate was a bad example because it doesn't take one, but I don't know. I suppose if read actually took it from the end, but I didn't notice. If right, well, I suppose if seek does. Do we ever read? We do some writing. So that write for is that what we want? So that writes to a socket. Is that socket secretly a um is oh I've gone somewhere. Is that socket so if we go right full is this, which it's annoyingly not letting me go to that bit. Um, so the sock is just a file descriptor, which shouldn't really call it a sock. Maybe we could call it a FD, but I mean, we're kind of using it in network terms as a socket, but a socket is actually just a file descriptor because in Unix, everything's a file. But that kind of confused me momentarily because I thought I couldn't just go if not not right full. And this we want to go to out FD, and we want to just give it that same data. And if that happened, we can probably do something like that. We could probably like do better and like buffer stuff. Like read a bunch into a byte array, or in fact just read the entire thing. And then write the entire thing. But I mean, I'll just do it byte by byte. It is what it is. But now we should get. It didn't like a thing there because that first one should be LD, all right. But we are getting D. That's all right. So this did a bunch of reading and writing. So I think actually it's slow, but whatevs. I will actually just go U and we'll call it an AT, or we'll call it data, and we will malloc it, and we will just malloc the entire packet length. And here we can check if the data equal null, then like there's some sort of memory error. So we'd probably just go equals x temp fail, and we go to end. And now that we've allocated the whole thing, we can get rid of like this whole loop, and we don't really want to do the B of data. We actually want to do data and then packet thing. And then here we want to do that same thing. Packet length. And so then it should just write two large chunks. Well, it should do one large chunk of read and then one large chunk of write. As we can see here, we have read a bunch of bytes, then we look like we've seemingly got all three of the things. And what's interesting is it only wrote that, but I wonder what these were. I mean, this is now implemented, I would say. Actually, no, it's not. We need to still. Uh, yeah, so once we get the whole piece, we need to do a thing. Which should happen after some stuff. Yeah, it's interesting that we read like a bunch of things. Oh, yeah, I see. We've read that much out of that, and then we write that much. And now we're just hanging somewhere. So I guess here, if we're maybe expected pieces, and we can minus, and if maybe this do the old prefix. In fact, I'll actually might make it explicit. So if the expected pieces equal to 0, then we're probably done here. So we could probably how to get out of this. So this is like all in a big switch, which is all in a big true. Um, I don't really want to do it here. Well, actually, no. Maybe. Uh, maybe I want to do something like size t sent requests, and that can start off as 0, and then we can pieces received. Yeah, that looks fine. And then we can have, well, sent requests equal to 0, or pieces received is less than sent requests. I think that should do the trick once I do some things. So for each piece that we request, we will want to go sent request plus like that. And if we do another one, we just need to tuck that in at the end. When we get a bit field, we don't really do anything. We just say we're interested. And then expected pieces, we will say pieces received plus plus. So we're adding them both up. And I guess here we don't really need to do that. Maybe another check we can do up here is if sent requests equal to 0 or pieces received equal to sent requests. Maybe even greater than equal. Which it kind of is like a weird thing. That wasn't really what I wanted to get. Maybe just that one. Unexpected piece. Maybe I will even piece message. And we'll just say that, and maybe go to end. So if we do something like that, it should check that all out. It should like quit, I think. Yeah, so now it gets to an unreachable part, which is at the end, which I think now is not unreachable. Or maybe we just go to end um, once we get the last piece. No, I think it's now no longer unreachable because it's kind of the path that we've chosen. We're doing while we're still waiting for pieces, pretty much. And so at this point here, we should look at what piece has, and it has like a bunch of things. And if I go SHA-1 some of this, or even I could go your BitTorrent hash of that, and it should give the same number. I mean, it looks roughly the same in like the middle, end, and the start. I'm pretty happy with it. So what can we also do? We can go and bring out our info, and this will have a piece hash of hopefully one that kind of matches that. So the 6E22. And if we download, say maybe, come on, you. If we get the first one, we can't get the first one. We need to go something like that. I do let it happen anywhere. But now if I do this sample and if we do the hash of the piece, it should be that first one. And if we, come on, get out of that and then go up. And then maybe do 2 we haven't got. So if we do that 2 and then do a hash of it, it should be. Oh yeah, that ain't right. Well, actually, no. There's a giant error where I wasn't reading. So it looks like we're not actually doing the last byte properly. It's kind of interesting that it. I think I want to when I get a message, say what message is, because I am doing that for other things, just so I can see when this piece comes in. And so if we do that again, we get that. And why was 2 not working? Did we get a piece? Yeah, so we didn't even get the piece. So we get an unchoke and then we write a bunch of things. And that packet length is like before everything. So we write a bunch of things. And then we can't read any more packets. Interesting. What I might do is do a little TCP flow and maybe do this and then do this and then just do that. And now if we do this, it should kind of show what happens. So we sent that, we sent a 6, and then we sent a index, which is out of that, it is just that. I'll believe it. Then we send a 1, 2. Actually, no. 1, 2, 3, 4. Yeah, that's the piece index, which is 2. 0, 1, 2 makes sense. And then begin 1, 2, what is it? 1, 2, 3, 4, and then 1, 2, 3, 4, and then this final one will be our length, which will be 1, 2, and will be a shorter length than other ones that we're sending. But then we get nothing back. And I'm also wondering what this crap is. So I guess what I will do is do that. And this should send a bunch more. Did I get in time? Can we not get to the top? So I guess we need to do this. And maybe we do that. Yeah, so now we should have a bunch of things. So that was the first file. So if we look through it, we send through this 6, which is now looking for the first packet, and then it's got a 4. Then like this stuff. And then if we look below that packet, kind of, I mean, it's we get to this again, and then this time it did not work. Looks like it did work though. Yeah, so we send a packet and we still get a response. But it says that we. Oh, so we actually did get a piece there. I saw a weird error as well, which I wonder if I get that there. This size of request payload not equals 16.12. That kind of seems weird. So it seemed like it got one, then not another. So maybe if I run that a few times, it might. Gosh. And this is before it can even read the thing. We've seen a bunch of things. We sometimes get a response, but then sometimes not. I think potentially because we are trying to read this here. So maybe this needs to be while not. It's a bit gross, but we can do that. So while we can't get a packet length, we kind of need like a cooldown. I mean, what I can do is do that and see if it works. No, endless loop. So it is there though. That is happening. So I wonder what I want to do here. If so we can say send request equals that pieces received equals that. And maybe just those two. And pieces received and we are missing a I'm gonna go back to our loads. Got fat thumbs. It needs to be that. Yeah, so we have sent requests, but we're just not getting it for some reason. Which I wonder why. I wonder. I honestly do. It seems like we should get it, but it isn't. Right. So at the end, we'll assume that we got the piece. So I guess the hash, we now need to do some hashing. Fix me check hash. So we need to get the. I kind of want to get rid of that and maybe get that down there. That's this area that it's saying. So why do I think it's going to be 16? Or it's 3 times 4, right? Which is 12. Makes sense. I don't know what I was thinking with that error. I've forgotten where it is. Cool. So get all that, but I have the pairs, the pieces, the pieces, the pieces. So that I think I want to open up. Maybe get what is it? Commands at commands. That's kind of where I put all the sub commands. And if we look at info file, because the info prints out the piece hashes, so we can see here how it's kind of done. So the piece hashes are actually just literally the index of the piece into that piece hashes, and yeah, I guess we just need to hash some stuff. So I think we can probably reuse well piece hash. It puts more stuff on the old stack doing it this way, but what I want to do is basically get all of this and bring it across here and change the info to info, change that to piece and do that everywhere. Yeah, that's all right. Chuck an S in front. Right, so this is going to get the piece hashes. But it's not really because we need to get it from. So I think we do actually want to store the bytes as is. Well, kind of. I don't know. Yes, I think I do need to, but the problem is that I don't. Well, I do know how much it is. It is piece length. Perfect. So yeah, we can actually just go. Uh, you went 8p. And what's this going to be? This is going to be we can call it data, and this can be malloc of piece linked sign. And I feel like I've already done this malloc somewhere here, just for that particular data. But that is not really what I want. So I guess if this happens, this is a red equals ex temp. Just work it out. Right, so now that we have the data, we can, instead of doing the fseek, we can probably just go data plus begin. And not do the write to the file just yet, and not do this allocation, and not do that, not do that, not do that. And that's just going to read it into the byte. And so here we will just take that data, and what's this? This is like the size. So this is going to be pieces length size, and potentially go like that. I don't know where that one came from. So if that is that, and then we want to do, well, we also want to do if not right full, and we can give it the outs fd, and we can give it data, and we can give it piece length size, and here we can with data, we can free the data. Probably a decent idea to free it. So, but in before there, we where's missing a thing? There's something missing somewhere. Right. So if this is the case, we can probably just go to the end as well. But this will be equals IO X IO error, and then finally ret equals X. Okay, but before we do this, we probably want to do if mem CMP, is that what we can do? Yeah, and we can just go the 2-byte regions. So we will have data, and we will also have something, and we will be looking for SHA-1 digest byte length. And if this not equal to 0, then we probably want to complain about stuff. STD error, piece hash mix match. I don't know. You go to and cool. So now we just need to work out where this is. So this is going to be gosh, we hit it down here. So we just need to get the index that we're looking for, then just times it by SHA-1 byte length. Easy. It's like a weird thing to go to. You do you then. Cool. So that we haven't declared memcomp. We will just shove it up in string. Do we not have string? Is const void long int. Yeah, we did stuff up there. We just had strings. Strings doesn't actually exist. Right, so what do we want? want two data regions. So this is getting the index of where it is. So now we want to go pieces data plus that. And it doesn't like this void arithmetic, but yeah, it's kind of weird. But if we actually call this a unit 8 like that, we should be able to do it. Yeah, because now we're basically saying it is this many bytes. So now this isn't doing it because it's still trying to get that last one. But if we get this, it should get a mix match. That's kind of annoying because I thought I had it. So I guess what I'll need to do is maybe like expected and print all this on a line std air and same thing down here. So that is what we expected. Copy paste from the other side. And then we can come down here and then say actual and maybe add in a space just to make it right. And so here we probably want to just get it from data. Well, no, we need to get that piece hash. Yeah, so yeah, so we're not comparing that. We're comparing piece hash. Boom. But it doesn't hurt to print this out. So we will get that. We don't actually need to do that loop. And the IDX is that, and this we already have set perfect, and the actual. So here we just want to change this. I think we just want to do something like data. No, piece hash. Piece hash of that, and we can get rid of that. That right doesn't like a bunch of things. We need to do an F print here, and F print here, and same down here. You know what I find odd? Why F print here has a stream at the start. Just wondering, because just wondering. Can't remember why I thought that. Because like F right, yeah, that's right. Right, so it still doesn't like stuff here. Where are you closing? Way up there. Wait, that ain't right. Something like that, and you can come back in one. That looks about right. So now it should go off and do a bunch of things, and it's written some bytes. And so what I want to do is maybe get a piece hash of, I don't know, like, well, let's find my thing, maybe 5, it can equal to 41. See what happens. And so this should hopefully crash and say, nah, failed. And maybe I want to put one extra space in front of it. If you can't work out why, it's because I want them to align. And that makes it heaps easier to work out where things are screwed up. So there you've got a byte that is different. That's just how you know. And then the rest are doing some stuff. But we know that it was working. but the only problem is that last byte. So if we do that, and if we say also test 0, um, it should theoretically work. So we do have some problems in this. The Oi, no, I don't want to do that. Can we like get rid of that before I do any comments? Yeah, because I just want to get that. I don't want to do that and then do that and then back up there. So what are we doing? We truncate some stuff. Well, I don't really need to truncate anymore. But it is what it is. So if we go to F truncate, don't actually need to do this. And because I'm now storing the whole thing into just a bunch of memory, it kind of means that we can go and how do we do this? If we get this, but then I might find that and then do that, it should just pump out a bunch of stuff to the screen. Boom. So like we can also do that. And I don't know if that is, yeah. So yeah, I guess this is kind of working as expected. I don't want to do anything there. Decided I don't need that. What's in here? Don't really want any of that. Cool. So that's that. So what I might do is commit this up. And what do we want to put in this commit message? Handle peace here messages. Still failing on last piece for some reason. So we can do that, and I'm also not doing that parallel programming, which that could be quite good to do at some point. But I guess what do I want to do? Can we do tests this, but test it just on the code, see how the tests are going. So we have tests that do stuff here, and if it will fail because it can't get that last message, and I would think that they will test that, but hopefully it will pass some tests. I'm kind of interested to see. Just running, boom, look at it go. Just running tests. Yeah, so it's doing a thing. It's downloading some things. It was happy with it. I'm happy with it. And then here we had some failure. But that's all good. I'm happy with that. Made some progress. It's good to make progress after a bit of hiatus, even though it was only like a couple of days. On that note, thanks heaps for watching these videos. It does make my day when people comment and stuff saying that they enjoy it. And I hope to come back and do more stuff. Until then, I'll see you.